All right, so we're going to keep rolling with the zeros of polynomials section here. This is example 5. So it says, what are the solutions of this equation? So at this point, now they're giving us a cubic set equal to another cubic and asking us to find the solutions. Remember, though, solutions are the same thing as saying zeros or x-intercepts or roots. All the things we've been doing this whole section so far is this. But now, since it's set up like an equation like this, what we actually want to do is we want to move everything to one side so that we have one single polynomial set equal to 0, and then we can figure out what values are going to make that happen. You don't have to go left or right. It doesn't matter which side you move it to. I just like when my lead term is positive, so I'm going to move this smaller lead term over. So I'm going to subtract the 2x to the third. I'm going to subtract the 5x squared. And I'm going to add the 3x, which there's no like term for it, but I'll just put it here anyway. All right, so now I'm going to have nothing over here. And I'm going to have a single x to the third. 8 minus 5 is going to be 3x squared plus 3x plus the 1. So now that's the problem I need to solve. If you did what you're supposed to do yesterday, you know that we want to try to factor this. This doesn't, we don't know how to factor this. It is factorable, but we haven't learned a way to do it yet. So at this point, we're like, well, I don't know how to factor this. There's no GCF, nothing like that. So I'm going to go right ahead and I'm going to graph this. Because we're now in the route of what we learned most recently, which is graph it to see if it has any real zeros. It's definitely going to have 1. It might have 3. We'll see. So we get it all typed in here. Nope, not quite. +1. And then we graph it on a standard window. Hold on. So on the standard window, we get a graph looks like this. Definitely has a 0 right there. I think it's at -1. Let's check the table. Yep, at -1. This graph's at 0. Now, we only really see that 1, 0. And so that means one of a couple things. We do know there has to be 3 solutions. Whatever the lead, the highest degree is, that's the number of solutions you're going to have. So we need to find 3 solutions. One of them is at -1. So the approach we're going to take on this is I'm going to start listing my solutions here. And I'm going to say, I know that x equals -1 is for sure a solution. That's part of my answer. What I'm going to do now, though, is I'm going to take this one solution we know, and I'm going to divide it out of here. Because if I divide it out of here, that's going to show me what I have left to work with. And if you remember the ones we did with the quadratics, that's kind of where I'm at. So I'm going to take -1. I'm going to do it over here where I got some space. I'm going to take my coefficients. I'm going to do my synthetic division. So 1, 3, 3, 1. All right, so we multiply, and we add, and we multiply, and we add, and we multiply, and we add. Okay, good. So what is this? This is x squared plus 2x plus 1. Which, if you take a look at that, that actually factors. Because there are factors of 1 that add to 2. They would, of course, be 1 and 1. So this actually factors to x plus 1 times x plus 1. And this might start making sense to you now as to why I did this, because so the zeros of this would be -1 and -1. And we already knew one of the zeros was -1. So this has 3 solutions. They just happen to all be the exact same thing. The -1 from the graph and the 2 that we got from factoring basically indicate that this has a multiplicity of 3. And that's it. So that's the idea. When you go into these questions, you know how many solutions you need. Whatever your degree is, 3rd degree, 3 solutions, 4th degree, 4 solutions, 10th degree, 10 solutions. Once you've identified all 3 of those solutions, then you know you're done. And in our case, it was the same solution 3 times. We saw some yesterday where sometimes you got one that was real and you got a couple that were imaginary. That can happen too. Okay? All right, so let's go and take a look at some more. So we do have essentially more of the same here. Let's go ahead. I'll do this one with you guys. So this one's actually really nice because when you go to start moving things to the same side, and again, it doesn't matter which side you move it to, but these are actually going to cancel each other out completely. We're not even going to have a cube at all. So, all right, so I'm going to add this 7x over, and I'm going to subtract this 6 over. So now I've got nothing, no x cubes. So I just have 5x squared plus 5x minus 30. And this is just a quadratic. And quadratics are awesome because we know how to factor quadratics. Specifically, we'd start with taking out this GCF of 5. So pull a 5 out of everything and get x squared plus x minus 6. And that factors, because factors of -6 that add to 1 would be 3 and -2. So this problem factors perfectly. So x plus 3, x minus 2. And now our solutions are easy. So what are our solutions? It's the values that make these equal 0. So it's going to be -3 and +2. And we know we're done because we had a quadratic and it ended up having 2 solutions. Okay, even though the original problem is a cubic technically, once you move it to one side, this is what we're talking about. Is this problem only has 2 solutions because it only goes to the second degree. All right, go ahead and try the next one on your own if you want to. See what you can do with it. All right, so I'm going to pick up right here basically. So I moved everything to one side. So I added the x to the third, added the 2x over, got to here. I then saw that I could pull an x out of everything as a GCF. I was still left with a cubic, which means I didn't know how to factor it. So I went ahead and I graphed it. So I'm not worrying about this part. I'm just worrying about what's in parentheses. When I graphed what was in my parentheses there, it looked like this. It's like the first problem we did today. Actually, it's almost exactly the same because you see it crosses at -1 as well. We can see that on the table here as well. So I'm going to do exactly like we did a second ago, and I'm going to take this -1. I'm going to divide it out of this polynomial. Let's see what we get. So multiply and add, multiply and add, multiply and add. So this is going to be just x squared plus 0x plus 2. You don't have to put the 0x if you don't want to. And let's kind of take a pause as to where we're at. So what are the solutions that we know for this problem so far? This first x we factored out is giving us one solution at 0. If you put a 0 into here, this whole thing becomes 0. -1 we saw from the graph. That was a solution. So we know 2 solutions of the 4 that we need to find. Now we've got ourselves to this quadratic. Unfortunately, this doesn't factor. There are no factors of 2 that add to 0. It's not going to happen. So this one has to go to the quadratic formula. Again, refreshing from what we did yesterday. So my b is 0, though. When b is 0 is kind of cool because you're going to have 0 plus or minus 0 squared minus 4ac all over 2a. So the 0 plus or minus really just leaves it as a plus or minus. And then we're going to have the square root of, this will be just -8 under there, over 2. And what does that simplify to? Well, the 8 we can break down to -4 times 2. Because remember, we want to pull any perfect squares we know out of there. And the square root of -4 is going to be 2i. So we get plus or minus 2i root 2 over 2. And lastly, the 2 divided by the 2 will cancel each other out. So it's actually just plus or minus I root 2. And that's going to be our other 2 solutions, plus or minus I root 2. And this one is a doozy. So that's a lot of doing to get to that kind of end result there of how many solutions there are. But it is 4 solutions. The first 0 you factored out, the -1 you got from the graph, you divided that out and got a quadratic that you had to but you had to solve with the quadratic formula because it had imaginary solutions. And that's the 2 imaginary solutions. So grand total of 4. Again, that's really as hard as those can ever get. But it is a tough problem for sure. By contrast, the next problems are actually pretty easy. So if you remember back at the start of this whole class, Algebra 1, Algebra 2, when we started doing inequalities and when is a graph positive versus when is it negative, that's what this stuff's going to be. When it says things like we're dealing with inequalities by graphing, what are the solutions of x cubed minus 16x less than 0? In other words, when is this graph below 0 on the graph? You are going to almost exclusively want to just graph this and look at it. So for any of these inequality problems, you see an inequality with polynomials, we're going to want to graph it, and then we're going to look at the graph to answer the question. So I'm going to put in just the left side of this, x cubed minus 16x, and I'm going to take a look at the graph. All right, so my graph looks like this. I'm just going to sketch it here so I don't have to have the calculator up here the whole time. So it goes up, comes down, goes back up. All right. What's key are the numbers that it crosses at. And I believe we can just get those from the table. So you have -4, 0, and probably +4. Yep. So this is -4, 0, +4. The reason why those are important is when this is saying when is this graph less than 0, Less than 0 means below the x-axis. So it's less than 0 here and here. And we just have to write those as intervals. So again, remembering this from back in the first semester, this interval would be everything from -infinity to -4. And this interval would be everything from 0 to 4. And that's it. Okay? Don't overcomplicate those. These are actually definitely not bad at all. You're going to graph it in the calculator. You're going to use the graph to then identify the intervals. So I'd like you to try these two. I'm going to go ahead and work them out, and then I'll put it up so you can check your answers. All right, if you're into trouble on the first one, it happens to have decimal values. Okay, when you go to find this one, it's not at -5 or -4. It's at -4.73. You should remember how to find those. Remember, when you want to find a weird number like that, it's second calc, find the 0. If you're using decimals, you can just click right on it. But it is perfectly fine for these to be decimal values. But you do left bound, right bound, and this one's at -1.27. And then this one is at 0. So once again, we now know the numbers. When is this graph less than 0? It'd be from -infinity to this number, so -infinity to -4.73. And this little bit here, so from -1.27 to 0. Okay. Then the last one here is actually not bad at all. This one gives you kind of a weird W shape when you graph it. Look like this. But the numbers are all whole numbers. You got -2, -1, 1, and 3. So once again, read the problem and say, when is the graph greater than 0? So now it's when is it above the x-axis? So that's here, here, and here. We're going to have 3 intervals for this answer. So -infinity to -2 would be one of them. -1 to 1 would be another. And 3 on to infinity would be the last one. And there we go. All right. So you're going to see some of these in the assignment today and hopefully see how things are going. Again, this 3-5 is a fairly tough section. So if you're running into trouble, if you got questions, let me know if you need help with anything.